What's good, everybody? Welcome to another live stream with Mr. Peters. Today, we're going to be talking about simplifying algebraic fractions. So, before we actually start that topic, I'm going to go back to regular fractions and I'm going to touch on that a little bit so that you guys could understand just the foundations. And this lesson is going to be very important when we're talking about multiplying, dividing, and adding and subtracting rational expressions. Really hope you guys find this video helpful. So when we're talking about regular fractions, we know the numerator versus the denominator. But the most important thing for us to add fractions is that the numbers at the bottom or the numbers in the denominator have to be the same, right? And typically your teacher talks to you about the lowest common denominator. And that's just basically the number that both of these, or the factor, I mean the product, product that both of these numbers go into. So I know that 4 and 3 both go into 12, right? So when I rewrite my fractions with a denominator of 12, I would now go back and multiply the top and bottom by whatever number it is that will give me 12. So I multiply 4 times 3 to get 12, and I'm going to do the same thing to the top part of the fraction. So 1/4 now turns into 3/12. Now, when we go back and we do the same thing for 2 over 3, I know 3 times 4 gives me 12. And whatever I multiply the bottom by, I also have to multiply the top by. So now 1/4 plus 2 over 3, when they have the same denominator, it's going to be 3 over 12 plus 8 over 12. And once we simplify, we would get 11 over 12 as a final answer. So now that we have that basic foundation down, we're now going to go ahead and practice when it comes to adding and subtracting rational expressions. All right, so let's start off with number 1. So we got 4x All right, so the way that I like to teach this subject is typically in 4 steps. So the first thing that we want to do is to look at the denominators, right? We know the denominators are not the same, and that's the issue that we have. Cannot add if we don't have the same denominators. So after we check our denominators, we're now going to simplify wherever we can. And when we talk about simplifying, guys, we're talking about factoring. So I'm talking about this trinomial here. We're going to break it down. So once I rewrite my problem, 4x, the factors that would make this a true statement would be x plus 1 times x plus 5. And when we look back at our factors, when we multiply 1 and 5, we're going to get 5. And when we add 1 and 5, that's going to give us 6x. So we know that we're correct. And then I rewrite the other side of the problem. And now I'm noticing that the denominator I need is x plus 1 times x plus 5. So now that we notice this second fraction does not have x plus 5, so what we need to do is to now make sure that we have the same denominator. And for us to get the same denominator, I need to multiply the top and bottom by x plus 5. All right, so we have x plus 5 in the bottom. We bring it up to the top. And now we're going to have the same denominators. So what I like to do at this step is to make this all one problem, right? Because it has the same denominator now. And we can now add the numerators. So 4x stays the same. And then 1 times x plus 5, that is just x plus 5. The value doesn't change because anything we multiply by 1 is just itself. So at this step, we have x plus 5. So when we add fractions, guys, remember denominators don't change, right? We just have to have the same denominator. And now that we have the same denominator, we're going to add what's in the numerator, our like terms, and then see if we could simplify anywhere. So when I go ahead, I'm going to have 5x plus 5 all over x plus 1 times x plus 5. So before we go back, before we go forward, let's backtrack some. So when we look at step number one, we looked at our denominators, right? We noticed that we had to factor x squared plus 6x plus 5. After we factored it, we noticed that now the denominator we need is x plus 1 times x plus 5. So as a result, we went to the second fraction and multiplied it by x plus 5 so that now we have the same denominator in both the fractions. And as a result of that, I made this one whole equation where we add this part with the x plus 5. Now, anytime you get your final answer, guys, when we're talking about fractions, your teacher says to do what? Exactly. Always check to see if you could simplify. And what I notice right here is that I have a greatest common factor. So if I take out 5 from the top, I pull out the greatest common factor of 5, I'll have x plus 5 on the inside, okay? And then this is all over the same denominator. Our denominator did not change. The only difference now is I have x plus 5 in my numerator and x plus 5 in my denominator. So you guys know anything divided by itself is 1. So I could cancel these two out, and my final answer would be 5 divided by x plus 1. So this is the main topic that we're going to be talking about today. We're going to do a few more examples for you guys. And if you have any questions, any concerns, drop a comment down below. I will try my best to respond back to you. And like I said, thank you guys for joining us today on our live stream. All right, so let's switch back to black. All right, let's see what does problem number 2 say. So we have y squared All right. So starting back over, I'm going to try to just go a little bit slower for the second example. But the first problem, I just wanted you guys to understand what exactly we're talking about. So step number one, we're looking at the problem. We notice that we do not have the same denominator, right? So now we move to step two. What could we factor? What could we simplify? So this is what we could do. So we're going to simplify this bottom, right? So we're going to have y squared plus 4y all over, let's see, y plus 2 and y plus 4. So when we multiply 2 and 4, we'll get 8. When we add, we'll get 6. That's correct. And then over on this side, we have 3 over y plus 2. Now that we looked after simplifying what we can, I noticed that this second fraction does not have the y plus 4. So before we could actually combine those top numerators, we have to multiply this second fraction by y plus 4. So we have y plus 4 in the bottom. We multiply 3 by y plus 4. And now we're going to rewrite our fraction. So the first fraction stays the same. And then the second fraction now, we're going to have 3y plus 12 on top. And that is all over y plus 2 times y plus 4. Let's make sure that I did this correctly. Yep, I believe I did that correctly. So we're good. All right, so now we're good, guys. So now what we're going to do, right, just had to double check the work. It's always important that you guys do that. We're now just going to focus on adding our numerator because we have the same denominator. So what we're going to have now is y squared stays the same. 4y and 3y gives me 7y. And then we have plus 12. And this is all over the same denominator of y plus 2 times y plus 4. Now remember, after we combine our numerators, right? And we have what we think is our final answer. We always have to check if we could simplify. So the bottom, there's nothing for us to do. But when we look at this top part, I could definitely simplify that. So when we simplify the top, we're going to get, let's write our two parentheses out. We're going to get y plus 3 times y plus 4. And when we double check, we know once we multiply 3 and 4, that gives us 12. And when we add 3y and 4y, that's going to give us that 7y in the middle. So we know we are good to go. I rewrite the bottom of my fraction, y plus 2 times y plus 4. And now at this very last step, right, we're going to double check again. Is there anything we could simplify? Y plus 4 cancels with y plus 4, and we are left with y plus 3 divided by y plus 2. So, like I said, guys, if you follow these steps and you just remember to always double check and simplify, it's very hard to get these problems wrong. But in our next example, we're going to go into our next example, and there's a little small trick that I really want to make sure I touch with you guys. Okay. All right, so let's go into problem number 3. All right, so problem number 3 of this video, we start back at the top of our problem solving process. So when I look at this problem now, the first thing I want to do is look at my denominators. They're not the same. Second thing we're going to do, what can I simplify? So we're going to simplify that denominator there. So we'll rewrite the problem, right? There's nothing that we could do here. That's simplified for the most part. We have 28x, and then this is all over, and let's write our factors out. So with this one, so remember when we have this negative sign, guys, that lets us know that our signs are more than likely going to be the opposite, okay? Let me make sure I said, yeah, that's the opposite. So when we look at this, guys, we want something that when we multiply, we're going to get a -6, but when we add, we get a +5. So we know the larger factor has to be positive. So the way I'm thinking is this has to be x plus 6 times x minus 1. When we multiply 6 and -1, we're going to get that -6. But when I add +6 and 5, that'll give me my +5. So factoring is such an important part of these rational expressions. Please make sure you double check factoring. I'm going to link a video down below for you guys in case you need a review on that topic. All right, so now we're looking at this step, guys, and I'm going to switch to blue because we noticed that, hey, in our denominator, we have x minus 1, but we're now mixing x plus 6. So what I'm going to do, let's put x plus 6 right here. Let's put x plus 6 right here because we're going to multiply. So once we multiply, we'll get 4x squared plus 24x. And this is all over x plus 6 times x minus 1. And we're going to rewrite the second part of this problem. And just for you guys to know, if the order of the factors aren't the same, that's fine. So here you see I have x plus 6 and x minus 1. And on the other side, I have x minus 1 and x plus 6. That's absolutely fine, guys. Just make sure that it has the same signs. Now, if it's the same number as an x plus 6, and then over here is x minus 6, that is not the same. But if it's the same sign, same factor, but it's just written in different orders, it's the same thing. All right, so after this step now, guys, what we want to do, we're going to make one huge problem, and I'm going to switch back to black so this pops out. So we have 4x squared plus 24x. And guys, what I want to talk to you about is this right here. And I forgot the x. Just remember that this negative lets you know that you are subtracting, okay? So in this problem, I know we're talking about adding. Don't think that you're subtracting a negative and it turns positive. No. you're subtracting a positive number, so it's just regular subtraction. I've seen students misunderstand the sign and how it applies, and they will get it wrong. Now, if this was a negative, it was minus negative 28x, then we would actually be adding it. But in this problem here, right, even though it's positive, it's still a subtraction problem. So just make sure that you subtract. So when I make this into one whole fraction, we need to make sure we have that subtraction sign in front of 28x. And then I'm going to write the denominator. So when we simplify now, guys, we're going to have 4x to the second power minus 4x, right? We're just talking about this part right here where we did positive 24x minus 28x. And this is all over the same denominator. But if you guys notice or you remember, after we get the same denominator and we combine the numerators, add or subtract, we now have to check again if there's anything that we could simplify. And I'm looking right here and I know that I have a greatest common factor of 4. So when I pull that out now, I pull out 4, I'm left with x squared minus 1 all over x plus 6 times x minus 6. Oops, not x plus 6 times x minus 1. Ooh, sorry, guys. I was thinking ahead of the problem. So let's get some more space over here because I really need you guys to see this because there's a small trick. And they don't want you to really figure it out. So right here, we have the difference of two squares. So we have to break that top part down even further. So once we break it down, right, denominator stays the same. Now, when we are in the top, we have 4. And when we have the difference of squares, we know it's going to be the same factor with opposite sides. So we just take the square root of x squared, which is x, the square root of 1, which is 1, and then we're just going to flip the signs, meaning 1 is positive, 1 is negative. This is what happens with the difference of squares. Also have videos on that if you guys want to check it out. But let's get back to the problem. So now everything is factored out. Now we're going to go back and we're going to simplify by crossing out x minus 1 in the top, x minus 1 in the bottom. So my final answer would be 4 times x plus 1 all over x plus 6. And like I said, if you guys have any questions, any concerns, just let us know. Drop a comment down in the comment section for us. We will try to reply as soon as possible. But at this point of the video, we're going to switch over a little bit and we're going to focus now on multiplication and division of rational expressions. All right. So let's go back to our regular fraction example. So we have 1 over 4 divided by 2 over 3. So the basic rules when it comes to dividing fraction is keep, change, flip. So what that means is we keep the first fraction the same, we change a division sign to a multiplication sign, and then we flip the second fraction, all right? So this is going to be 3 over 2, and then we'll multiply straight across to get 3 over 8. So when we're multiplying, right, or when we're dividing fractions, when we start off dividing, it's going to turn into multiplication. And when we're multiplying fractions, they do not have to have the same denominator. And that's the biggest difference between adding and subtracting fractions, multiplying and dividing. So with that being said, let's now jump into some rational expressions where we're going to be dividing and multiplying. All right, so where's my first one? All right, let's write this down. Okay, x to the third, 6x squared. Okay, perfect. All right. So now we're switching over to, like I said, multiplying, dividing rational expressions. And I love to teach this in 3 steps. So the way that I like this, and I think it's simple, is number one, we're going to keep, change, flip. We're going to factor, and then we're going to simplify. And I'm going to show you what I mean. So we're going to keep the first fraction the same, right? So 2x squared plus 4x minus 6 all over from 4x plus 12. We're going to change that division sign into a multiplication, and then I'm going to take the reciprocal from now. So that means I have x to the third minus 6x squared minus 7x at top, and 3x squared minus 3x is at the bottom. Now at this step, right, we are now going to factor and simplify wherever possible. And we have a lot to simplify. So let's look right here. What we could do is pull out a greatest common factor of 2 and divide all our factors by 2. So when I pull my 2 out, I'm left with x squared plus 2x minus 3. So that's the first thing we did. Then we're going to go to the bottom. If I pull out a 4, we're going to be left with x plus 3. All right. And then I'm going to go one more step. I'm just going to simplify this whole side, and then we'll go to the other fraction. So we're focusing up here because the bottom is done. So when we rewrite the bottom, right? Let's rewrite the bottom. 4 times x plus 3. We're going to factor this top, and we know that our factors, let's make sure. We have 2 times, let's write our 2 parentheses. We're going to have x plus 3 times x minus 1. So now this first fraction is completely simplified. And remember, guys, math is a puzzle, so you didn't have to do it in the same exact order as I did. As long as your steps are correct, you're going to get the problem right. Right? So now we're going to go over here, and I'm going to simplify this side. So off the bat right here, I'm going to take out an x because I noticed there's an x at every term. So once I do that, I have x times x to the second power minus 6x minus 7. And then on the bottom, I'm going to take out a 3x, which will leave me with x minus 3 on the inside. Okay? So now that we've done that, the denominator is going to stay the same. So let's just write it. We got 3x times x minus 3. Stays the same. Now, in the top part, we had this trinomial, and we want to factor x squared minus 6x minus 7. So for us to do that, let's write our factors out. And let's see, what is our answer? So we want to multiply to get 7, add to get 6. Let's take a double check at the notes. What did I use again? I think that would make sense. So we have x minus 7 and then x plus 1. So now, guys, we've done the first step, keep, change, flip. We've factored everything out, right? And now we're going to simplify. So remember, when we simplify fractions, we could simplify top with the bottom, right? So we could do x plus 3 with x plus 3, right? Something that's on the top versus on the bottom. Or we could cross cancel, meaning I could do, let's see, is there a cross cancel in this one? Oh, I see what I did wrong. Made a mistake, guys. So this should be minus 1. There we go. Or we could cross cancel with x minus 1 here and x minus 1 here. So this is why it's also important to double check your work. You guys have seen I made a mistake. Hopefully no one caught that. All right, so we cross cancel x minus 1 with x minus 1. Then I have x plus 3 with x plus 3. Now what I'm left over with, and let's make sure I did this right. Let's make sure that I did everything right. Let's see. I do everything right. Let's make sure. X plus 1, x plus 3. Okay, okay. I think I seen what I did wrong. Is that it? Let's make sure. Let's go back. So 3x, we pulled out 3x. That's x minus 1. Let's make sure x minus 7, x plus 1, x minus 1. Let's see. Okay. Is this what I had? Let's see. Take out 3x. Okay. I think I'm good, guys. Just had to double check. So now when we go through, we're going to have 2x times x minus 7 times x plus 1 all over 4. And at this step, guys, oh, hold on, not 4. Let me make sure I did this right. 2, this is 4, 12x. And now at this step, what we could do is simplify 2x and 12x. So we're going to have, let's see, divide by 2, we're going to have x minus 7 times x plus 1. And this is going to be all over 6. So as you guys can see, right, when we're talking about dividing and multiplying rational expressions, guys, this is why I try to keep it in 3 steps, because you could definitely get lost in the work, as you guys just seen with me. So now that we're done with the first example, we're now going to move on to the second example for the problem of the day, I mean. All right, let's get going. All right, so problem number 2. All right, so we wrote this problem down again. Grab a quick sip of water. All right, so we're on the second problem, guys. And we start off with our first rule. So we're going to keep this first fraction the same. So we rewrite it, change my division to a multiplication sign, and then I'm going to flip my fraction. All right, so that's the first thing we need to do. Now that we've done that, we need to check to see what can we factor, and we have a few things that we need to factor. So I'm going to start on this right side because this side seems a little bit more simple. So we know our denominator stays the same, and then when we look at our factors, we're going to have x plus 2 times x minus 1. All right? And then when we go to this side, let's see if we could factor this out. And for the purposes of the video, guys, I'm not writing out my factors, but if you write out your factors, these are going to really help, right? So when we look here, we want to multiply to get 27, add to get 6. The only combination from the factors of 27 are 3 and 9. So as a result, we have x plus 9 times x minus 3. And then we go to the bottom and we're going to factor as well. So the same thing happens. When we multiply, we get 18. When we add, we get 11. So we have 1 times 18, 2 times 9, 6 times 3. 1 and 18 when we add will never give us 11. The same thing as 6 and 3. So this is why teachers stress so much just to write your factors out. It's less thinking and it makes it easier. Now I know off rip, this has to be it. Okay. So now we go ahead, we have x plus 9 times x plus 2. I know both of my factors are positive because when we multiply, our answer is positive, and when we add, our answer is positive. So at this step now, we're going to cancel what we could cancel out. So I have x plus 2 with x plus 2. Remember, we could cross cancel. They don't have to be one on top of the other, but they can. X minus 3 with x minus 3, that's simplified to 1, so we don't have to write it. And then the last one, x plus 9 with x plus 9. So when we look at this problem right here, all we're left with as a final answer would be x minus 1. So I really think these three rules are very helpful and makes the process a lot easier. We're now going to go on to what I will call the last problem of the day. We really hope that you enjoyed this live stream. Like I said, comment down below if you have any questions on this video. If there are any videos you guys would like to see in the future on our channel. And we will be back next Wednesday with another live stream so that you guys know. All right, so last problem of the day. So with this last problem, I wanted us to focus on a problem where it's already multiplication. All right. And when it's already multiplication, I believe it's a little bit easier, but it's actually the same exact steps, guys. The only difference is we don't do that very first step, and I'm going to show you what I mean. So if you remember a few moments ago, I said, hey, I teach this in 3 steps when we're talking about dividing rational expressions. We're going to keep change flip, right? Meaning we're going to keep, I already explained it. I'm sorry, guys. Then we're going to factor where we can, and then we'll simplify. But this, when we're talking about just multiplying rational expressions, we skip that first step. So the first thing we want to do is check if we could simplify. And what I noticed is I can. I have the difference of squares right here, difference of squares right here, and I have a trinomial, right? So